Now that we have seen some basic terms essential for understanding lines connected with angles, it's also important to understand some extended basic properties like the collinear points or the non-collinear points on the line. So what are collinear and non-collinear points is what we're going to discuss in this session. Collinear points. When do we say collinear? When they are linear to each other. So when are the points linear? If all the points lie on the line, they are collinear. If all the points do not lie on the line, they are not collinear. It's very simple. The word collinear itself says they are linear, therefore we have collinear implies all points must lie on a line. Then only we say the points are collinear. Say for example, I have a line, or this is a ray in which I have 3 points P, Q and R. Let's see if they are collinear. Clearly I have the point P on the line L, and I have point Q which is on the line L, and the point R which is on line L. So since PQR lie on line L, therefore they are linear to each other. Therefore PQR are called collinear points on L. The points are collinear if they lie on the line L. They are not collinear if they do not lie on the line L. Is how we understand collinear points connected with lines and angles. Let's see an example of a situation where we have non-collinear points. For example, I have a triangle ABC. I clearly see that if I take this line L, A and C lie on L, but B does not lie. Since A, B, C do not lie on the same line, since A, B, C do not lie on the same line, therefore A, B, C are non-collinear. Is how we understand the non-collinearity of the points. The 3 points must lie on the line L for the 3 points to be collinear. If one of the point does not lie on the line, though the other 2 points lie on the line, all the 3 points are said to be non-collinear. Non-collinear do not lie on the line. Collinear, the points lie on the line L, is what we learn as the learning outcome. Now that we have learnt some basic terms and properties in lines and angles, now comes the essentiality of recognizing the different types of angles involved when 2 lines intersect. Types of angles is the session about. Types of angles. Now that we have seen 2 different lines intersecting, we have them intersecting in different ways. Say for example, I have the 2 rays In the first case, passing from P, I clearly see that this angle, if I represent with theta, is less than 90. So any angle which is less than 90 is called acute angle. Say for example, I take this as x. So if the angle is less than 90 and greater than 0, then I call this angle as acute angle, is how we understand the formula number 1. Secondly, if I take a line which is exactly perpendicular to the other line, so ray 1 and ray 2 are perpendicular, then this x equals 90, then x is called right angle. If the angle is 90, that angle is called right angle. If the angle is less than 90, it is called acute angle. And if the angle is greater than 90, is what we are going to discuss further. An angle greater than 90 degrees. Let's investigate. If this is x, then any angle which is greater than 90 and less than 180, an angle which lies between 90 and 180 is called an obtuse angle. Is how we see the 3 different cases of an angle: less than 90, acute, equal to 90, right angle or perpendicular angle, and between 90 and 180, it's obtuse angle. So for these 2 lines or the rays, the angle is obtuse because it is more than 90 and of course less than 180. These 2 lines make an angle of 90 degrees because they are exactly perpendicular to each other. These 2 rays are obviously less than 90 degrees and therefore such angles are called acute angles. Types of angles connected with lines and angles: acute angle, right angle, and obtuse angle. Now that we have discussed about the types of angles, acute, right angle, and obtuse angle, now let's take 2 special cases which are very important. What if the angle is more than 180 degrees? Is how we investigate 2 special cases. Types of angles taken as special cases. Now in this case, as we have seen that an angle less than 90 is acute, when x is 90 it's a right angle, more than 90 and less than 180 is obtuse. Now comes the investigation on what happens if the angle is 180 or more than 180 as special cases for types of angles. Let me take the first case of 180 degrees. Say for example, I have the 2 rays which make an angle of 180 degrees. So when the angle is 180, then that angle is called straight line angle. So such a line is called straight line angle, is how we define for 180 degrees. Similarly, what happens if the angle is more than 180? Say for example, I have an angle this which is more than 180. So have this to be between 180 and 360. So here I have an angle more than 180 and less than 1 full circle. So such a case, x is called a reflex angle. is how we understand the straight line angle and reflex angle which are more than 180 and equal to 180. X equals 180 degrees implies that angle is called straight line angle as made by the two rays. X greater than 180 and less than 360 called reflex angle. Straight line angle and reflex angle has the special cases of the types of angles. What if the angle is 360? If suppose, let me end with the last angle which is 360 degrees. If the angle is 360 degrees, then I have a full circle which is formed. And hence this angle which is one full 360 degrees is called one full circle angle. X is called one full circle angle, is how we derive the different types of angles connected with lines and angles. Types of angles in special cases.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.